What's up, Simians? We got a great vid on tap right now. It's going to be a great in-class experience for everybody. And we're going to do a little foldable action in the NBs for the win. Okay, so we're talking about empirical and molecular formulas. So on the front of your little foldie here, which I have here on the P point, as we call it, you got empirical formula, molecular formula. So this is how it should look when it's folded in your notebook. I probably showed you this in class, I don't know. And then you open it up and you got the stuff inside. So empirical, here we go. Empirical formulas, or EF. I'm digging the rich red color. This red wears AirPods, is so rich. Empirical formula. So your empirical formula is going to be the lowest whole number ratio for a compound. The lowest whole number ratio for a compound. Now, if I was unclear, this is going right on the front. Oh, I can draw on this. Oh, but then it disappears. It's going here, an empirical formula on the front of your foldable. Okay, lowest whole number ratio for a compound. All right. So, for example, if you have something like, let's make something up here, O2N6. I don't think this would happen, but let's just roll with it. You have this. This is your molecular formula, which we'll talk about in a second. This could very well be the real compound you're looking at, but the empirical formula would be ON3. Okay? You simplified it. You divided each number by 2. So this is another thing to write down. If you're given a formula, you simplify the subscripts. Okay, so that's what we just did, right? In this right here, which is such a weird looking compound, it would be NO3 is a real, whatever. All right, so you're simplifying the subscripts of the formula. Now, on the other hand, if you flip your foldie around, we're talking about molecular formula, okay? So you can already see there's good examples on here of glucose and the molecular versus the empirical formula for glucose. That would have been a much better thing for me to use instead of making up, oh, this is so ugly, I can't even look at it anymore. I'm still gonna make the video though. So I'm gonna use the example that's actually on your foldable. Okay, so glucose would be C6H12O6. We know that. But the empirical formula, because we can divide each of these subscripts by 6, would be CH2O. Okay, that would be this is your empirical formula. Okay, so when we're talking about molecular formulas, the molecular formula shows the number and kinds of atoms in a chemical formula. Okay, so the molecular formula, like for glucose, would be C6H12O6. This tells you what's really going on. This tells you what their compound is really made out of and the number of the atoms in the actual compound. Okay, whereas your empirical formula up here shows you the simplest whole number ratios, the ratios that these things are combining in. So for every 1 carbon, there are 2 hydrogens and there's 1 oxygen. So the empirical formula is giving you the ratios. Okay, so hopefully that gives you a little bit of an understanding about what we're talking about when we talk about empirical and molecular formulas. So if you open up your foldie, okay, which I'm doing here on my table. If you open up your foldie, you'll see that you have an example that is asking you to determine the empirical and molecular formulas for antifreeze, for the compound that makes up, or that is, oh my gosh, Edward Lampert, the compound that is antifreeze. All right, so I'm gonna walk through these steps and I will label them. And I want you to take what I'm doing. You can pause the video as much as you want. rewind, whatever you need to do, take these and write them into the step categories on your foldie. All right, so we have automobile antifreeze is composed of 38.7% carbon. So there's our first thing we're going to need to know. 9.7% hydrogen and 51.6% oxygen. The molar mass of the compound is 62.1 grams per mole. Determine the empirical and molecular formulas of this compound. So we're going to start by determining the empirical formula. Okay, so I'm starting over on the empirical formula side of the foldable. Now, the first thing I'm going to do, this is before any of the actual steps, is I'm going to lay out what I know. So I know that this is made out of carbon, hydrogen, and oxygen, as many things are. So carbon I know is 38.7%. Hydrogen I know is 9.7%. And oxygen is 51.6%. Okay? I know that. So now comes step one. So the first thing I'm going to do, and I'll even label this for you guys. Okay, so step one, I am going to divide each percent by its given atomic mass. So divide each percent by atomic mass. Okay, so I'm going to start with carbon here. 38.7 is the percent value, dividing it by the atomic mass, which is 12.01. For hydrogen, I have 9.7 for the percent value, and its atomic mass is 1.01. For oxygen, I have 51.6 for the atomic mass, and 51.6 for the percent value, and its atomic mass, 16.00. Okay, so I'm going to divide all of these by the atomic mass. I have here for carbon, I have the percent atomic mass, hydrogen percent atomic mass, and oxygen percent atomic mass. Okay, so that is what I'm doing here. So when I divide that, I'm going to get 3.22 here. I'm going to get 9.62 here, and I'm going to get 3.23 here. Okay, so you can already start to see the ratio that's forming here. 3.22 and 3.23 are essentially the same. But this brings us to our next step, which is going to be, so now we're on to step two. You divide all of the numbers you just got. Oh, wrong color, so embarrassing. Okay. Divide all numbers from step one. Okay, and you can take what I'm writing and simplify it or change it however you want, as long as the idea is the same. Put it in your own words. That always helps you to remember better or analyze it better. So divide all the numbers from step one by the smallest number from step one. So when I say numbers from step one, I'm talking about these three numbers right here. Okay, these three numbers. So I have to find the smallest number from step one. And like I said, 3.22 and 3.23 are essentially the same. I guess technically it's 3.22. So we're going to divide everything here by 3.22. Okay, so this is step two, dividing everything by 3.22. So maybe to give you more clarification, here's step one, now here's step two. Okay, so I'm dividing everything by that number, and you'll see that that means that this is going to be 1, and this is also essentially going to be 1, and then this is going to be 3. Okay, and when you're putting this into your foldie, you can break this up however you want. You don't have to do it all straight across a line like this. You probably don't have enough room for that. You can break it up into separate steps however you want. Okay, so I just divided, and then I also, in doing this, step 3 is also kind of involved here, because step 3, or kind of point number, this is kind of more of a point than a step, I feel like. You need to round to whole or half numbers. So round to nearest, how do you spell? Nearest, that's right. Nearest whole or half number. Okay, so for these, I didn't get exactly 1 here, right? Because they're slightly different numbers, but it's close enough to 1 that I can round. And I didn't get exactly 3 here, but it's close enough that I round to 3. And if you're close to a half, you round it to a half. So let me put that this is, I'm gonna put step 3 kind of the equal sign because it's part of that. Now step 4 is a step that's only involved sometimes. If you get a half, double everything. So that's saying if any of my 3 numbers right here rounded to a half, if I had let's say 1.5 right here, then I would double everything. I'd multiply this by 2, this by 2, and this by 2, and my new answer would be 3, 6, and 2. Okay, so that's not the case here, but if I did have a half, I would multiply each of these 3 numbers by 2. Okay, so now I have my 3 numbers, and step 4 that wraps it, or I'm sorry, step 5 that wraps it up is that the answer, oh geez, wrong color again. Okay, the answers from steps 3 and 4 are the subscripts. Okay, so I have 1, 3, and 1. Now this is for carbon, this is for hydrogen, and this is for oxygen. So we stayed across the row for all of these. So that means that my final formula is going to be 1 carbon, 3 hydrogens, and 1 oxygen, CH3O. Okay, that is how you do it for empirical formulas. I will end this video now. I don't know how class went today, if I got distracted too much or you guys did. It's really either way. But if there's still time left, then go on to the next video, which will be on molecular formulas, the second half of your sweet foldie. Smash like.